Hello students, this is the third lecture of set theory. Now, we have already seen the operation on set and the terminology on sets, right? Now, in this lecture, the very important formula is coming that's called the De Morgan's law, and the formula what we have already studied. Now we will apply the formula on 2 sets, 3 sets, 4 sets, and more than 4 sets. For n number of sets, how to use the formula, right? And the competitive examination question, how to solve the question, that's covering in this lecture. So let's start the lecture and enjoy this.
Disjoint set means no elements in common. See, this is the triangle, no relation with the other triangle, right? No common portion is there, right? This is known as disjoint set, right? Disjoint means intersection is empty set. Intersection is empty sets means if one is A and other is B, so both the intersection you are getting as null set phi. You are not getting anything in between, right? With Venn diagram, it's always easy to understand, right? So number of element in between will be 0 in this case. You can say in Venn diagram, this is A and this is B. You are getting nothing in between. So we can say A intersection of B you are getting as null set, that's phi, right? The properties, right? Properties of disjoint sets. The definition for the disjoint set is two sets are disjoint if their intersection is the empty set, right? No element in common. With examples, we can understand, like if I'm saying one set A contain the elements 1, 2, 3, and other set contain the element 3, 4, and 5, right? Anything in common between? Yes, there is something common, that's 3. So this is not disjoint set. Something is common in this, right? But something unrelated things are written like Tamil Nadu and Mumbai related to 3 and 4. Obviously, this is disjointed set. 1, 2 with a 5 null set, always a disjoint set. But what if I'm asking 5 with 5? Think. Null set is there and again intersection with null set. Then how could we go for this null set? Right? So intersection is always the empty set in this case also. Okay, now next terminology, the difference. Next terminology is the difference between two sets. Difference between two sets. Usually this is denoted by the minus sign. Difference, we know that the first one is A and second one is B. The difference we have to take. Then this is called the minus sign. With the minus sign, this is taken as A minus B, right? The same way, right, this is A minus B. This was the first one, the bigger triangle was the first one, and the smaller triangle was the second one. So all the elements in A will be there, but the common portion we have to discard, right? Common portion we have to discard, so we are getting this portion. You can say again, this A minus B, right? But in this case, like M minus P in this case, this is for M and this is for P. So you are getting the C. Your answer for this will be C, right? But what if I'm going for C is P minus M? So this time P minus M, when you are writing P minus M, so all the portion that's contained in P and the common portion with M we have to discard. So you are getting these three portions, right? Again, you can see this. the portion, the complete portion was there, A, B, and all the universal set. These elements are the universal one, right? These are the universal one, right? Okay, and this is for P and this is for M, right? When we have to subtract this P and M, right, this P minus M is all the portion that contain in P will be there and subtracted the common portion that common with M, right? And this is for M minus P. Then again, this will be for P minus M. I guess everyone understand this. With the set notation, we can understand this easily, right? A minus B, right? So if it is given A minus B in this case, right? A is complete this thing, right? Circle, and B is this. So A minus this is the blue portion what you are getting is called A minus B, right? This B you have to subtract from this, right? So all the portion in A and we are subtracting the blue portion from A. So now the completely we are getting, this is your answer for A minus B, right? And what if B minus A? So this portion is known as B minus A, right? We are subtracting this A from B and the common portion of A will be subtracted from this, right? Now, the difference. The definition for difference is if I'm writing A minus B means X is such that X belongs to A but X does not belongs to B, right? In a like in this manner you can say in set theory also, right? This is A and if let you are saying this is B, A minus B is this portion, right? This is the portion that contain A minus B. अब ये मेरा A minus B है, कोई element X की अगर मैं बात करूं तो X must contain in A and not containing in B and A intersection B. These portion you are not getting this B, right? So the operation, and if we want to write down this in intersection form, this will be A intersection B prime. B prime is, if this is B, right, all the elements not contained in B is called B dash or B prime. So A intersection B prime. So all the elements outside B is known as B prime, and that intersection with A will always give you the answer what you required, the common portion of both this, right? Now, so we can with the numbers, right, we can understand easily. If I'm saying 1, 2, 3 and I have to subtract 3, 4, 5, right? So 1, 2, 3 is common to both, cancel out, so 1, 2 is the answer, right? If I have to subtract New York, Washington with 3, 4, so only the clear one, the first one, the elements are coming. No, not common, so we are not subtracting any common thing, right? 1, 2, subtract with 5, null set, again you are getting 1, 2, right? A difference of any set S with the empty set will be set S only, right? Null set means nothing is there, so we have to, right, subtract again with this, right? Now in the color gamut, right, if I'm taking color gamut of first minus the set of color gamut of second, so we know that this is called the difference one. But in this difference one, if we require the symmetric difference, what is the meaning of this symmetric difference, right? New terminology is there when we have to see the symmetric difference. Symmetric difference means first you have to take a case of when A minus B is there, then we have to take a case of B minus A is there, and both the portion we have to take the common one, right? Common one we have to reject. Means the symmetric difference of the set contain all the elements in either set but not both. So see, 1, 2, 3. In M, these three portions are there that is not contained in C, and this P contain these three portions that's not contained in M. But this is the portion that's contained in both M and P, right? So we have to subtract these areas, right? We have to reject these areas, and rest of the portion will be your answer. So you can see this style, right? This is your answer. This is known as symmetric difference. Hope you are understanding this. That's the reason I have taken this in colors, right? Symmetric difference, the symbol is this one, right? Plus with the circle, and we can write M plus with the circle with P, right? So few more examples are there. You can understand this easily. The definition of this will be, right, A steric B is X is such that X belongs to A or X belongs to B, but not belongs to A intersection of B. The common portion we have to reject, other than other portions will be the answer, right? That I was saying A union B is total, but we have to subtract A intersection B, right? For example, 1, 2, 3 steric with 3, 4, 5. So the common is 3, we have to reject this and all the other elements that is not common to both 1, 2, 4 and 5. Simple, right? Again, the example New York, Washington with 3, 4, nothing is common. So everything will be there in your answer, right? 1, 2 with null set 5, so no use of this null set in this form, right? If you are taking symmetric form, so we know that this will be S union phi minus S intersection phi, right? So again, you are getting S only, right? Now, the next terminology we are understanding there, we have already used this terminology, this known as complement. Complement of any set is represented as A dash, A bar, AC. In any way, we can write this. In some books, you will find A prime, A dash, or AC, right? A different form will be there. The meaning of this is the complement of a set is all the elements that are not in the set, right? Means if I'm saying this is the universal set, and in this universal set, this is A, so all the elements that not contained in A, right? The not contained in A is known as the complement set, right? This one, the person, right? This is M complement, right? M के बाहर के जितने भी portion है, you can take out the things that is known as M complement, right? If we are going for P complement, this is the P complement outside the P, right? Now, complement of two sets, right? If I'm saying A dash, this is for A dash, right? Other than A, we are taking all the elements other than A, right? B prime or B dash. What will be the B dash other than B, right? This is A dash, other than B will be this one. B is the white one, and other than B is the blue one. Okay. The definition, we already know that, but in mathematical form, we write that a dash a prime is x such that x does not belongs to A. All the elements outside A or U minus A, where U is the universal set. If I am saying U as a integers, then the complement of 1 to 3, all the integer except the number 1, 2, and 3, right? So the property, right? Property of complement, if you are taking a complement, then again taking complement, this will be no complement. A bar, then a one more bar, there is no bar, right? A union a bar, right? A union a bar means you are taking two things, one is a and second is a bar, so you are getting all the universe. All the universe will be with you only, right? A intersection a bar, so nothing is common, so this is phi null set. And now this is one of the very important theorem given by De Morgan. This De Morgan law is A intersection B. You are taking bar of the complete A intersection B. Means if this is a set, right, this is A and this is B. A intersection B, we know that this is the portion that is A intersection B. And bar means all the other portion other than this, right? So bar means I'm saying all the portion other than this, right? So all the outside portion. Okay. So that's we are writing A bar means other than A we are taking all the elements, and B bar other than B we are taking all the elements. The union of this means we are not taking only this portion, that's the intersection one, A intersection B, we are not taking this portion, right? That's the reason this A intersection B is in the bar is given there, right? Same with this one. So this is very important formula, right? And we have to use this in permutation, combination, and probability also. So remember this formula, right? We will use this formula, right? How to prove any identity like A intersection B is given, and this you have to prove B minus A. Both are written in a different form. One is the intersection form, and then this second is written in the difference form, right? In both way, we have to see like how to write down both the things. So we have usually 3-4 methods for this. We are just going for this. First is the basic set identity. Basic set identity means we have to put the numbers for you have taken A as the numbers 1, 2, 3, 4, 5, and so on, right? And B, or you have taken B as the something like this, right? 1, 2 numbers are common, and you can take like 4, 5, 6, 7, or 8, right? Now you have to take all the other numbers like A intersection B or A, B, C, right? The we can say in this A intersection B is A and B, the common portion is 4 and 5 only. Now B minus A, we know that B minus A is 6, 7 only, and B minus this 6, 7 only, so again you are getting 4 and 5. So both are same, right? With the numbers we can say this. Now the second, right, with the subset method of each other, we can Venn diagram you can use also, right? Set builder notation, right? In this portion also we can understand with the Venn diagram. See, A intersection B, this is the portion, right? A intersection B, right? Now B minus A, so this is B, first B minus A. So what is this B minus A? B minus of A is this portion. Again you are subtracting this with B, so you are getting the same elements in this, right? This is B minus A. Again, subtracting with B, you are getting B minus A, right? With the laws, right? Basic set identities. A intersection B, we can write this as B minus B intersection A bar, right? Definition of difference. Again, this minus we are converting as intersection. B intersection A bar is in the bar, right? Now this we are converting into this with the help of De Morgan's law, right? So B intersection A bar is B bar union A bar is in the bar, right? Again, B bar, bar and bar, two times bar, so no bar of A, to B bar union B. Now, B intersection now distributive law, right? B intersection B bar union B intersection A, and B intersection B bar is nothing but phi, right? This is B union A, or B intersection A, we can write A intersection B, both are same. Okay, so this is one of the beautiful way to write down. In one question we have used almost all the properties, right? This is one of the best example for you. You can understand it, like how this is going and go how to use the properties for that, right? So one example I'm taking this there, right? A is given, B is given, then find value of this. One of the easiest question you can say, right? A union B, then find this, right? With operation you can write, right? So this is all the natural numbers, A dash union A, right? Few of the examples you can understand this easily, like again this is given X intersection in the bracket this. You can solve this by numbers also, right? You can take the numbers and you can solve, or you can solve this by properties also, like distributive law, right? X intersection, both this, getting X intersection X will be phi, and with y, this y prime or y, this will be phi. So you are getting nothing in this, right? So these are the few of the examples, right? Now, for three sets, right? For three sets, like how we have to go. That's called inclusion, exclusion. This A, B, and C is given. When we have to find A union B union C. This A union B union C is, first I'm writing A, B, and C, right? But if I'm writing A, so I'm including this one time. When writing B, then again including this, right? So this portion A intersection B is coming twice. So I have to subtract this again for AC, subtract this again for BC, subtract this. But understand, while subtracting all this thing from one side, from second side, and from third side, we have subtracted this, the common portion, A intersection B intersection C, 3 times. So we have to add one more time, right? So first you have taken one at a time, right? One at a time, minus two at a time, plus three at a time, and if required, minus four at a time, and so on. So this is also valid for four sets or more than four sets, right? That you can see in this. This is known as inclusion exclusion principle, right? First, this is written one at a time, minus two at a time intersection, then 3 at a time, 4 at a time, 5 at a time, and so on. So this is very important theorem that's known as inclusion exclusion. You have to use this in function, in permutation and combination, as well as in probability, right? It's a very important theorem. Right now, few of the examples I have given for three sets A, B, and C. First example is for A intersection B intersection C, A union B union C, right? Second is A intersection B intersection C, and so on. So start with first A union B union C, but means you have to add all three. So what you are getting? The complete dispersion, right? Complete portion A, B, C, and common portion we have to write down once only, right? The intersection of all three means common to A, B, and C, right? Common to A, B, and C. This is the portion, right? Now, B intersection C, you can go with B and C. So B intersection C is this portion common to both. And again, you have to add A on this, right? So common portion you have to write down once, and this complete portion you're getting there. Okay. And same way, A minus B intersection C. So first B intersection C is this one, and A minus. So A is complete. When we have to subtract, we know that we have to subtract only the common portion with this. So this was the common portion. So subtract this portion, you're again getting the answer, right? Be careful. Now, one more example for you, right? ABC sets, right? Venn diagram for A intersection B complement. I said you this, you can write B dash, B prime, or BC. These all are complement only. Union A intersection C prime or C dash, right? So first we are writing B dash. So except B, all the elements, A intersection B dash, the common to both A and B dash. So this is the portion, right? The green one, right? C dash is right, except this C, A intersection C dash, right? This is the portion you are getting. Now, you have to add this and this. Union means you have to add both the portions, right? We have to add both the portions. So commonly the portion will become, right? But the common portion will be coming one time only, right? So imagine what will be the answer, right? See, the common, this portion is not there only, and all the portion of A is coming. This is A intersection B dash union A intersection C dash, right? So in next lecture, we will start relation,